Good morning, class. Is everything fine? How about your internet connection? Please type 1 if you have a stable connection. Okay, so everything is fine. So let's start. Before we proceed to our topic, let me first introduce myself. I am Shamir E. I graduated as Western Mindanao State University with a course of BS Ed or Bachelor of Secondary Education, major in Mathematics. You can call me Teacher Lim. As all of you know, I'll be teaching mathematics, and I do know also that many students hate mathematics. So please raise your right hand for those students who hate math. There's so many of you. So at least I think 60% of you hate mathematics. But don't worry, I'll try my best to make this subject and topic as fun as possible. Because I believe math is not that hard and complicated if it is taught by the right teacher. And I do hope that I am one of those right teachers. So let me first read to you our classroom rule. Even we are conducting our class online, we still have rules that you need to follow. Please take note and remember this. Our first rule is, if someone is speaking, everyone should pay attention. Are we clear? Okay, very good. Second, respect everybody, not just me, but also your colleagues or classmates. And the last is, if you are not interested, you may leave. You may do other things or sleep, but just don't bother people. Just don't bother your classmate. Am I clear? Okay, very good. Before we will proceed to our topic, let me first read you the objectives. So first is define modular arithmetic. So yes, our topic is modular arithmetic. And the second is solve some examples of multiplying numbers and as well as converting both positive and negative numbers using modular arithmetic. Third is demonstrate the understanding of the necessity of using modular arithmetic in real world situation. That is our objectives. I'll be showing you some videos about the topic modular arithmetic. So after this, I need you to divide yourself into 5 groups, and I will be giving some problem solving question that is presented in our presentation.
Hey everybody, this is Paul. Welcome back to another lesson in cryptography. In this video, we're going to be talking about modular arithmetic. Modular arithmetic is a very fundamental component of cryptography. So it's very important that we understand what modular arithmetic is and how to use it before we ever start learning about cryptography. Here I have a statement, and what the statement says is it says 3 is congruent to 5 mod 2. So essentially what that's saying is, in the world of mod 2, 3 and 5 are equivalently the same thing. So how exactly does that work? Well, let's look at this number line right here. We'll go ahead and place 3 on this number line. So there's a 3, and now we'll go ahead and place 5. And so now we have the numbers 3 and 5 on our number line. But 3 and 5 are two distinct numbers here. However, we're dealing with mod 2 in this case. So the 2 here in mod 2 tells us how many values we can have in mod 2. That means there's only 2 values in mod 2. So for every mod, the value starts at 0 and it ends at one number less than the mod. So one number less than 2 is 1. So for mod 2, the acceptable values are 0 and 1. If we were dealing with mod 3, we would have 3 values to work with, starting at 0, then 1, and going up to 2. 0, 1, and 2. 3 values in mod 3. 0 and 1 gives us 2 values for mod 2. If we wanted to take this further, we could take a look at mod 9, and the acceptable values for mod 9 would be 0 all the way up to 8, giving us 9 numbers. So I think you guys can see the pattern here. The mod number tells us how many values we have in our mod, and the highest number of the mod is always one less than the mod itself. So 3 goes up to 2, 2 goes up to 1, 9 goes up to 8. So how do we apply these values to our number line here? Well, we start at the 0, and for the moment we'll look at mod 2. So the possible values we can have for mod 2 are the numbers 0 and 1. So we start at 0, and then the next number would be 1. So then we would want to put a 2, but 2 isn't one of the acceptable values, so we switch back to the beginning. So this becomes 0, 1, 0, 1. So 3 has the value 1 in mod 2, and 5 also has the value 1 in mod 2 as well. So therefore, 3 and 5 essentially have the same value when we're dealing with mod 2. We can also apply this to negative numbers as well. So following this pattern, negative 1 would have the value of 1 in mod 2, negative 2 would have the value of 0 in mod 2, and negative 3 has the value of 1 in mod 2. So in mod 2, negative 3 is congruent to positive 3. And negative 3 is congruent to 5, because both negative 3, 3, and 5 correspond to the number 1 when we're dealing in mod 2. Let's take a look at this with mod 3 now. So when we want to plot the numbers for mod 3, we're going to use the same approach that we used when we plotted the numbers for mod 2. So 0 always maps to 0, and then we start counting up in mod 3. So 1 is 1, 2 is 2, and then we would want to do 3 next. But when we're dealing with mod 3, our only possible values are 0, 1, and 2. So since we've already got to 2 here, we start over at 0 again. So 4 becomes 1, and 5 becomes 2. So we just create this pattern all the way across the number line. 0, 1, 2, 0, 1, 2, 0, 1, 2, and it just keeps repeating. So therefore, all of the integers on the real number line will map to 0, 1, or 2 when we're dealing with mod 3. We can also take this in the negative direction as well. So going backwards now, starting at the other end, 2, 1, 0. So negative 3 is congruent to 0 in mod 3, and positive 3 is congruent to 0 in mod 3. Notice how I went backwards here in the negative direction, but if we read this left to right again, we continue the same pattern. 0, 1, 2, 0, 1, 2, 0, 1, 2, and it just keeps repeating. If we're looking at 3 and 5 in mod 3, 3 and 5 are not congruent. 3 is congruent to 0, and 5 is congruent to 2. So therefore, we would say 3 is not congruent to 5 when we're dealing with mod 3. But we can say 3 is congruent to 0 in mod 3, and we can say that 5 is congruent to 2 in mod 3. So this is probably a good stopping point for now for an introduction to modular arithmetic. In the next videos, I'll be covering how to add, subtract, multiply, and divide with modular arithmetic as well. So stay tuned for those videos. Thank you guys for watching. Have an excellent day, and if you haven't already, don't forget to subscribe.
So modular arithmetic 3 congruence to 5 mode 2. So as you observe, I have a what you call this Cartesian coordinate plane here, only the x-axis. So in mode 2, for every mode start with value 0 and less than the number of the mode. So our number of the mode here first is we have 2. So less than of the number of 2 is 1 and 0. So the question here is 3 and 5 and the mode 2. So first let's mark this 3 and 5. So our mode is 0 and 1. So here is 0 and 1, 0 and 1, 0 and 1, 0. So we observe that 3 and 5 are same, which is they are equally equivalent or congruent to each other. Therefore 3 congruent 5 mode 2 is correct. So take a look at this mode 3. In mode 3 we have 0, 1, and 2. For every mode again, start with value 0 and less than the number of modes. So the mode is 3. Therefore the value that start with 0 and less than the number of mode. Therefore our elements here is 0, 1, and 2, and so on. I'll be presenting again a video about example of modular arithmetic in positive numbers. And I want you, after you watch the video, I want to know your thoughts and explain your reasoning about the video that was presented. So take a look at this. Now we are in modular arithmetic converting positive numbers. So here is Rn, Q, M plus R. This is the left hand side, and this is the right hand side. This is the mode, and this is the remainder. Our problem 1 is 51 congruence to 1 mode 10. In order to get this 10, we need to 51 divided by 10. That's why got 8 these numbers, and our remainder is 1. So 1 times 10 plus 1 is equals to 51. Therefore 51 is congruent to 1 mode 10. So another example, problem 2. 25 congruent, need to just leave there a number which we will divide to 25 in order to get its value. So 25 divided by 4, here our mode is, so get your calculator. 25 divided by 4 is 6 point something. So get that 6 point. No matter how's the point, it doesn't really matter, just leave it. So 6 times so copy this, 6 times 4 plus the remainder. What is our remainder? 6 times 4 is, yes, 24 plus 1. The remainder is 1. Therefore, we copy this, 25 is equals to 6 times 4, 24 plus 1, which is the remainder, is 25 equal to 25. Only get the whole numbers when dividing this, guys. The point doesn't really matter. Therefore, our right hand side here is 6. So 25 congruent to 6 mode 4 is check. That's how you get modular arithmetic converting positive numbers. So we are done with the positive numbers. Now I'll be showing again a video about the mode congruence in negative numbers. So please watch the video carefully. So modular arithmetic converting negative numbers is rather hard compared to the positive numbers. So what we are gonna do first is that we need to find the right hand side number a greater number than 51. So negative 51 is equals to, we will number that will be times to 10, and that answer should be greater than 51. So the closest number is negative 6. We will use negative 6, guys, because this is negative here. So negative 6 times 10, and our remainder is 9 plus 9. So negative 51, 6 times 10 is equals to negative 60 plus 9. Negative 51 is equals to negative 60 plus 9 is negative 51. So therefore the negative 51 is congruent to 9 mode 10. So let's have another example. We have negative 37 congruence, leave it blank, and mode 5. We will find this number later. So negative 37, again we will divide times the number here, and and the number that we will put here should be greater than the 37. So what do you suggest? What number? 7? No. 7 times 5 is only 35. Yes, 8. We will use 8. So negative 8 times 5, that would be negative 40, right? And it is greater than 37. Therefore, our remainder is 8 times 5 is 40. 40 minus 30. And the remainder is 3. Therefore, negative 37 is equals to negative 37. Since 8 times 5 is 40 plus 3 is equal to negative 37. Therefore, our remainder here is 3. Are we clear? Okay, let's proceed. So I prepare again, and I think this is the last video, and it is about multiplying numbers in modular arithmetic. So we have 5 groups. Right? So after you watch the video, each group will appoint a representative to offer their thoughts of the video that was being shown. Am I clear? Good. So now we are in modular arithmetic, multiplying numbers. In all of video that was presented, and compared to the positive and negative numbers, this is the most difficult one. So you should pay attention. 8 times 11, our problem number 1 is 8 times 11 mode 3 is congruent to 1. So let's see. So n is equals to q times m plus r. So our n here would be 8 times 11 is 88. Is equals to, we will find this number that would be multiplied, and the result should be greater than or lower than 88 rather. So the number that is we will using that would be multiplied to 3 is 29, since 29 times 3 is equal to 87, which leaves a remainder 1. Therefore 88 is equals to 88. That's how we get modular arithmetic multiplying numbers. Also, I will suggest another method. This is called a grouping mechanism. So put a bracket, 8 mode 3 bracket times, at again 8 here, 11 mode 3 and bracket. So first let us do this. 8 times 3. So what number we will use to that should be lower than 8, less than 8 rather? Yes, 2. 2 times 3 equals to 6, therefore our remainder is 2. So here we have 11 with 3. What we will use, that we will get less number than 11. Yes, 3. 3 times 3 is equals to 9. The remainder is 2. Therefore 8 and 11 is congruent to remainder 2. So we can now rewrite the value of 8 and 11 as the value of 2. We found out that 8 and 11 is congruent to 2 mode 3. So let's do it like this. 2 times 2 mode 3, since this is mode 3, right? And the remainder is congruent, both in 8 and 11 is congruent to 2, therefore we times it or multiply it. 2 times 2, 4. Mode 3. So, just do it like this, guys. 4 is equals to, since our mode 3, what number we will use to get a less number compared to 4? What? Yes, 1. 1 times 3 is equal to 3. Therefore, the remainder is 1. Therefore, 4 is congruent to 1 mode 3. That is one way to find out in multiplying numbers. We watch a total of 3 videos. So it is modular arithmetic converting positive numbers and modular arithmetic converting negative numbers, and also modular arithmetic multiplying numbers. So here's my question. What is modular arithmetic? Can someone share their thoughts or idea about the modular arithmetic? Yes, please. Okay, very good. So give Mr. Kufra a round of applause, please. Second, define integer. Okay, Miss Angela? Yes, define integer. Very good. Give him a round of applause again. And the last is define congruence modulo. Who want to define? Okay, Mr. Tamus. Very good. Another one. We have Mr. Balmos. Go ahead. Very good. So all of your answer is correct. You clearly understand and watch the video carefully. Now, is math that hard? No. Because we are in the easy one. If we are in the hard one, I don't know if it is still easy or hard. No, I'm just kidding. So, modular arithmetic is a system of arithmetic for integers which consider the remainders. In modular arithmetic, numbers wrap around upon reaching a given fixed quantity. This given quantity is known as the modulus to leave a remainder. An integer is a number which with no decimal or fractional part from the set of negative and positive numbers including 0. If a and b are integers and m is positive integer, then a is a congruent to b modulo m. If m divides a to b, we use the notation a congruent b mod m to indicate that a is congruent to b modulo m. So take note that sign 3 equals, you call that congruent. Remember that is called congruent. We can say that a congruent to b mod m is congruence, and that m is its modulus. Its plural is moduli. If a and b are not congruent to modulo m, we write a not congruent b mod m. Congruence modulo. You may see an expression like a congruence to b mod c. This says that a is congruent to b modulo c. We will discuss the meaning of congruence modulo by performing a thought experiment with a regular modulo operator. Let's imagine we are calculating mode 5 for all the integers. So, is the picture being shown is clear? Okay. Suppose we label 5 slices 0, 1, 2, 3, 4. Then for each of the integers, we put it into a slice that mathematical match the value of the integer mode 5. Think of these slices as blocks which hold a set of numbers. For example, 26 would go in the slice labeled 1. because 26 mode 5 is equals to 1. Above is a figure that shows some integers that we would find in each of the slices. It would be useful to have a way of expressing that numbers belong in the same slice. Notice that 26 is in the same slice as 1, 6, 11, 16, 21 in above example or in the picture that I have shown. A common way of expressing that two values are in the same slice is to say that they are in the same equivalence class. The way we express this mathematically for mode C is A congruence to B mode C. The above expression is pronounced A is congruent to mode. The above expression is pronounced A is congruent to B modulo C. So 1. So this is the symbol for congruence, which means the values A and B are in the same equivalence class. Mode C tells us what operation we applied to A and B. When we have both of these, we call congruence modulo C. Example given is 26 congruence 11 mode 5. 26 mode 5 is equals to 1, so it is in the equivalent class for 1. 11 mode 5 is equals to 1, so it is in the equivalent class for 1 as well. Note that this is different from A mode C. 26 is not equal 11 mode 5. We are done with our discussion. Now I need you to solve the following. You can answer it by group. So please answer the following question that I have shown. After you finish your work, I need you to take down or write your assignment for tomorrow. So answer the following. You may submit it on me through Facebook. You can add me you can direct message me in this account. So present your work. PM me. Message me your work, guys. Okay. I see. A lot of you got the correct answer, so we are done with doing works or with solving by groups. Let's now solve this individually. That way I will know if every one of you did learn. So tell whether the following integers are congruent or not. Show your solutions clearly. Number 1, 35 congruence 3 mode 7 and 5 congruence 2 mode 7. The second is 8 congruence 4 mode 2 and 10 congruence 2 mode 2. And the last is 65 congruence 16 mode 13. You have 10 minutes to answer this. So to answer this problem. Are you done? Okay, very good. Again, PM it, chat your answers on our, send your answers on our group chat. So, we are done. We are almost done. What have you learned in our lesson today? So, please raise your right hand to answer. Please raise your right hand if you, and tell me what have you learned today. Okay? Very good. Give him a round of applause, please. So, anyone? More? Okay. Thank you. So, I am very grateful to you since most of you did learn something. So, which part of this activity you enjoy the most? You enjoy it all? Are you sure? Or you just saying things to make me feel good? No. Very good. Again, clap your hand for yourself. You did great. And I'm very thankful and grateful that you did learn. So again, thank you. That would be the end of our discussion. I do hope that you will never forget those topic and discussion that we have been discussed this day. See you when I see you. Have a nice day and be safe, everyone.